Hello and welcome to PV Magazine Roundtables Europe program. Thank you for tuning in, and I'm genuinely excited to be part of this first session because it's the first time that we've tackled the issue of sustainability in the solar sector at one of our roundtable events. And for those of you joining us for the first time, we're hosting 4 roundtable events across 2 days with more than 50 speakers. We had more than 2,000 registrants, and yesterday for the asset management and quality roundtable sessions, we attracted over 900 attendees. Now, on to today's session. You could be forgiven for thinking within the solar sector that as we produce clean energy, as we're part of the solution to climate change, that there's really no imperative to adopt sustainability. In fact, our focus should be on scaling as absolutely fast as possible and deploying as well. Well, today in our Sustainability Roundtable, we'll be hearing why solar sustainability matters. And this roundtable is a part of our PV Magazine Up initiative. And I'm very pleased to have initiative partners, Coveme and SMA, as a part of the discussion today. And I want you to get involved too, so please don't hesitate to ask questions. You can do that via the event app to our presenters and also our panelists at any time, and we'll feed them through the event and get to those questions after the event also, if we can't get to all of them during the main stage. Marion, you'll be feeding the questions through to our presenters and panelists today. You also researched and completed an article for the June edition of PV Magazine Global about one of our Up Initiative partners' endeavours when it comes to sustainability. What did you learn?
Exactly, Jonathan, thank you, and welcome also from my side to everybody who is tuned in today. Well, I wrote about SMA's ambitions, and I phoned up their sustainability manager, Matthias Schepers, and he told me about how the solar industry leaves an impact on this planet and on its society, like other industries as well. So he really told me about all the different ways to consider sustainability, because it isn't just about lowering the CO2 output from the manufacturing processes, but it's also about considering things like design for recycling or omitting certain materials. But he was adamant and explained to me time and again that it isn't about fixing one of these issues in isolation, but considering and quantifying all of them together to then design a product which performs better on all of these metrics at the same time. And it was a really interesting insight, and it's exciting to see how companies like SMA are embarking on this journey and hopefully will inform the solar industry as well to do similar things, because obviously panels and trackers and batteries have to also be more sustainable.
And you can read about that in the June edition of PV Magazine, which comes out in just a few days. Now, obviously, this is a virtual event. We're not here in real life for obvious reasons, but there are many ways that you can get involved and also network and enjoy all of the things that a live event brings to you. Marion, can you tell us a little bit about how that works?
Well, exactly. So for many of you, it will be the first time you use an event app like this. And if you discover any problems, you will find an info booth button somewhere on this app, and you will find some help there. Also, there are many ways besides this main stage live stream to get involved, and please do so. Pro tip, you can open this event app in multiple browser tabs at the same time, so you don't have to leave this live stream. So you can listen to it, and at the same time, chat with other attendees, get in breakout sessions. You can answer our live polls. We have them running for each session and at the end of each day. Give us your feedback there. Also, after each session, we have Meet the Speaker Zoom rooms where you can meet our speakers. You can meet some of our moderators, and we can discuss. You can break out in group discussions and attendee-to-attendee discussions, and you can meet our event partners in their expo areas.
Excellent. So lots of networking opportunities available, and thanks to FEMA, who is our networking partner for this whole Roundtables Europe program. We also have a number of platinum sponsors, and I really want to thank them for their support across all of our roundtables over these 2 days: DuPont, ET Solar, and Smart Energy. Well, let's get cracking with the Sustainability Roundtable. And our first presentation addresses why, it gives us the big picture, I suppose, as to why sustainability in solar matters. So that's the question. We can always think we're doing a good thing. This is the solar sector after all. Isn't it a luxury to think about sustainability when in fact we're in quite a cutthroat business and prices are always trending down? Well, this next presentation will provide the big picture. Our first presenter has more than 40 years of experience as a PV researcher at Stanford University and with leading companies like SunPower. Most recently, he was the chief scientist at Trina Solar. He's now the managing director of the consultancy Amrock. Pierre Verlinden, welcome to our Sustainability Roundtable. Thanks for joining us from Australia.
Thank you, Jonathan. It's great to be here, and good morning to everybody.
Well, very nice to see you. Without further ado, I'll let you get on with your presentation.
Okay, thank you, Jonathan. So, good morning, everybody, and I'm going to talk about the sustainability challenge for the PV industry. And going directly, we already know, all of us, that to fight this global climate change issues and to meet the objective of the Paris Agreement, we know that the world needs to be net zero CO2 emission by the middle of the century, by about 2055. And our vision is that PV will play a major role in that energy transition. And we know already from calculation that we'll need something like about 70 or 80 terawatt peak of PV installation by 2050. And this, in conjunction with hydro, wind power, geothermal, and biomass, this will power directly or indirectly all the energy sector of the world. That includes electricity, transportation, short distance or long distance transportation, or all the industry processes. But the big question is, we know that we can do it. The PV industry has demonstrated that it can do it, but can we do it sustainably? And there are many ways to look at sustainability. We could look at it as from an energy point of view. What's the energy payback time? We could look at it from a CO2 emission point of view, but also chemical consumption and solid waste and effluents and pollution. Also the material usage, and particularly the rare materials, the rare metals that we use in our solar cells or PV systems. Can we recycle the product, and can we capture the valuable material? And also, financially, are we able to grow, and how fast can we grow? And it's very important to look also at all the parameters that will impact the sustainability, like the efficiency and reliability of the panels and the performance ratio, how we install the panels and where we install them. So this picture is probably a bit complicated, but you will have access to all the slides after the presentation. We look at the whole life cycles of the PV system, from raw material to recycling. And for each step of that life cycle, materials and energy are needed, and we create effluents, gas, liquids, and solid. At the end of the life cycles, we have a recycling process, and some of the materials can be recycled here. So we need to look at the whole chain. And what is very important, it's what we call the cumulative energy demand, or CED. And we have to look at as a primary energy. So what the amount of megajoule is needed to manufacture and operate such a system. Then what's very important is the energy payback times. It's basically the CED, the cumulative energy demand, divided by the energy produced every year. And we have to transform that into primary energy. That's why the energy produced is divided by the grid efficiency, which is typically in the range of about 30%. And then we calculate the energy return on investment, which is basically divide the system lifetime, typically in the range of 30 years, divided by the energy payback time. In terms of recycling, there are different technologies that are used for recycling modules. It could be a chemical process, or it could be a mechanical process, or a thermal process, or a combination of all of those. Unfortunately, as of today, only a small part of this whole recycling process is used, and we recycle very few materials from the entire PV system. We still need to go a lot more than that. Today, we recycle about 100 megawatts of PV modules per year. In 10 years, the volume will be 10 times larger. So that corresponds to roughly about 150,000 tons of PV system, PV modules and steel and frames and cables, etc., that we need to recycle. Now, if we look at 1 terawatt of PV system, and we know that we need to grow several terawatts per year in production, 1 terawatt includes about 56 million tons of steel and 47 million tons of concrete, 2.3 million tons of silicon, 42 million tons of gas, and 29,000 tons of silver. If we look at the worldwide production of those materials, there's no big issues, even for silicon. We know that the production of silicon grows with the growth of the PV industry. We have to be careful with aluminum and copper, but we certainly have to pay a lot of attention to silver. For 1 terawatt of PV annual production, we will use 94% of today's worldwide production of silver. And this curve here represents the growth of the PV demand for silver compared to the total production of silver in the world. And you could see by the 1 terawatt level, about 2025 or 2030, we'll use 100% of the production worldwide. We also have to look at other materials, and this graph shows the abundance of elements on the Earth crust. And you could see the bar here, this line, represents 7 orders of magnitudes below the concentration of silicon in the Earth crust. And you could see that elements like silver, cadmium, indium, tellurium, gold, bismuth, all those elements should not be used in PV modules if we want to produce at the terawatt level. Now, if we look at in terms of energy, 1 terawatt of PV system is embedded about 3 times 10 to the 17 joules of cumulative energy demand. Fortunately, we will save over 25 years, we will save about 1,000 times more in energy demand. We will save about 25 billion tons, even if we have consumed about 700 million tons of CO2, and we'll generate about 32,500 terawatt hours. We know also that the lifetime of PV module is actually much longer than significantly longer than the 25 years. It's about, in average, about 32 years. So this graph represents the energy payback time of a PV system, roughly about 1.7 years, and the amount of CO2 that is equivalent per kilowatt hours produced, roughly about 29 gram of CO2 per kilowatt hours, compared to production of electricity by coal or gas or petrol or nuclear. The other thing that's important is the financial sustainability, and I'll skip that very quickly, but what is very important is that we need to generate enough cash to grow the production capacity, and we have to do it quickly. If we don't do it quickly, by 2050, we're going to see a major downturn in the industry, which will be very detrimental. And I thank you very much for your attention, and I'll welcome some questions.
For that, Pierre Verlinden. And Pierre will be taking part in the Meet the Speaker program on our app. So if you have questions you'd like to follow up with Pierre directly on. One quick question, Pierre, in terms of trends for material usage and energy usage in PV production, are you seeing things develop the right way? Which way is it trending? Are we becoming more efficient in these regards, or are we continuing to, as price continues to fall and production continues to scale, are we not paying enough attention to that?
Well, yes, we do reduce the consumption of silver, which is the most important one. A few years ago, we used to consume about roughly about 30 tons of silver per gigawatt. Now we're down to about 20 tons of silver per gigawatt. But at the terawatt level, we need to be much lower than that. We need to be roughly about 5 grams per watt. So that represents for wafers, for example, for solar cells, that would represent about 30 grams of silver. And right now we typically consume about 130 milligrams of silver. So 30 milligrams of silver per wafers, sorry.
Okay, and Pierre, how much metal in a module can be recovered from recycling?
That's the biggest problem. So the problem is to do it cost effectively, and for the moment there's very little material that we recycle. We recycled cables and copper, but that's about it. And if we want to recycle the silver, it's a chemical process, and it's for the moment it's not very cost effective.
And which recycling method do you believe has the highest material value but the least environmental impact?
That's probably a question not for me, more for chemical engineers.
Okay, well, we have PV Cycle on in our panel discussion after this. I'll refer that one. And also, what is your reference for the 32-year annual average lifetime of a module? What was your reference for that? One of our attendees is asking.
Well, that was just an article that came out just a few days ago. And I think it was even mentioned in PV magazine that people have looked at the lifetime of PV system around the world, and found that the average was roughly about 32.5 years.
Excellent. Thank you very much, Pierre Verlinden, the Managing Director of AMROC. Thank you for joining us on our first Sustainability Roundtable event.
Thank you, Jonathan.
And on to our second presentation today. As one of the sponsors, the gold sponsors of our PV Magazine Roundtables Europe program, we're very pleased to have German production equipment supplier Vonnedenner. And now we're going to hear from Sebastian Gatz, who's the Vice President of Photovoltaics for Vonnedenner, giving us the perspective of production equipment and machinery in terms of sustainability outcomes. We heard from Pierre that solar needs to get very big, and Vonnedenner is addressing one of these challenges through their equipment platforms. Sebastian, you have an experience at the big names in German PV module production, SolarWorld, Manns, Meyer Burger, or not even German, European, and now you're at Vonnedenner. I'm really looking forward to your insights, and thanks for joining us today.
Thank you, Jonathan. I appreciate this nice introduction, and I welcome all people here to my talk about how scaling in equipment design contributes to a more sustainable PV production. But before coming to the details, I just want to give you a brief introduction of the Vonnedenner Group. We are an equipment manufacturer for where we are focusing on vacuum coating technologies for different applications, for architectural glass, and for sure also for photovoltaics. We are a family-owned company which is managed by the granddaughter of the founder, Manfred Vonnedenner. With his work as a scientist, inventor, and entrepreneur, he contributed to various business areas. Here are just some key inventions from him which helped for the breakthrough of, for example, in the television industry, for scanning electron microscopy, and also for semiconductor industry. And his spirit of constantly facing and also mastering challenges, new challenges, is still in the company's DNA, deep-rooted. One example of this is the success story of the thin film mass production equipment. Here you do see the annual chart for the thin film technologies, where we're looking at CIGS or cadmium telluride, where it ends up in efficiency well above 22%. And now it's a question how to transfer this technology from R&D to pilot and to the mass production. And we do offer systems for all of this. And this is one spring things. However, you have to look and to reduce the cost per watt, and therefore you have to increase the productivity or the throughput of the system, and you see it here in this range. And this has an impact on the capex. With increasing substance size and throughput, you decrease the cost per watt, but it has also an impact on the operative expenses. And I come to this also later. On this slide, you see an example for the capex of the sputtering system, PVD machines. So we are talking about, on the left-hand side, glasses which are smaller than generation 4. And then our system, the Pianova system, which is able to process substrates in generation 4 sizes, and the Xenia system, which allows you also to process Gen 6 substrates. And you do see here, by just introducing these systems, you can reduce the capex by a factor of 6. On the other side, we offer also a system for the monocrystalline silicon market. You do see here an example, the heterojunction technology on the top left side, where it allows you efficiency of well 24% and even above. And one key process step here is to do the coating of the transparent conductive oxide on the front and on the rear. And we do offer systems here for both. And this is a platform on the top right side with 3,600 or 5,500 wafer per hour. And we introduce now also a new platform, the so-called Xenia L, with throughputs up to above 10,000 wafer per hour. And you do see that this increase in the throughput gives you also a decrease in the capex and also in the opex, which ends up in the end also in a reduced cost of ownership. And on the left-hand side, you see the capex, which is needed for 1 gigawatt. So when you apply throughput of 3,600 wafer per hour systems, this is a starting point. By increasing the throughput per system, you need for sure less systems and also less material, what you need for this raw material, and also less energy to build up the system. And this comes with a decrease in the investment which you need at the end, which at the end gives you up to 60% less investment for the 1 gigawatt. On the right-hand side, you see also that applying exactly the same processes, you do see also reduced operative expenses. So for the new platform, Xenia L, with 8,000 or 10,000 wafer per hour, up to around about 20%. And this comes with a very let's say, smart magnetron design, high target utilization rate, and the advanced heating system for this in order to reduce this. In this slide, you see how a layout look like when you go to the gigawatt scale. So you need basically just 2 of the Xenia system for 1 gigawatt. And on the right-hand side, you see some examples of the open circuit voltage in the mass production, which is well above 240 millivolt, in the average record for 744 millivolt, which allows you efficiencies in the 24% range. However, in addition to the scaling of the equipment, we also have to look in our own side how to produce these equipment, and we use therefore partly also own solar cells or the modules on our roofs and on the facades. Here, an example of the thin film facade, and here you see also example of the crystalline. So we have also here a mixture that allows you also a more sustainable production of the equipment itself. We do see also this trends for the solar cell and solar module manufacturer, where they also use their own produced electricity to run their facilities. And with this, I come to the end. And the first thing is that you look at the efficiency. This is a key for making more sustainable, the PV production, and the other one is also scaling. And there we offer here solutions for this, for different thin film and also for crystalline market. So at the end, not only economy, but also ecology profits from scaling up in the equipment.
Okay, Sebastian, thank you very much for those insights. In terms of specifically sustainability, so energy usage or material usage, what role do some of these production platforms, really at this gigawatt scale that we're talking, what kind of role does scaling and these big production platforms play in terms of these sustainability outcomes?
I mean, we do see the push from our customers for scaling it, obviously, due to reducing the cost of ownership of their end product. And this is a trend. They do not push us regarding sustainability. They push us for economic reasons. But this comes in parallel and does not contradict each other.
Okay, so as you scale and as you're driving for cost effectiveness, you're also reducing material usage and energy usage at the same time.
Exactly. So we look at this also in our production side. It's also from our side, the cost to produce our system, it's also related to material and also energy. And for sure, we have to look also at our side to reduce the cost on different levels, and therefore also reduce material, raw materials, and also energy, what we use to produce these systems.
Okay, and these production platforms are suitable for both thin film production and also crystalline silicon, because from a sustainability standpoint, of course, there's always a discussion about the carbon footprint and the energy payback of the various technologies.
Yeah, so we do have different platforms for different applications. This is for sure. So you do not use the same systems. But when you look, for example, for the crystalline part, we do apply the Xeanova platform for both for heterojunction technology, but also for TOPCon technology. So we can utilize the same platform for different applications for crystalline part. And a similar story is true also for the thin film part in our company.
Okay, Sebastian Gatz is the VP of Photovoltaics for Fonadena. Thank you very much for joining us today, and thank you to Fonadena for partnering with us on this event.
You're welcome. Thank you very much.
Well, we've had a number of perspectives already in terms of the necessity for sustainability at the terawatt scale, particularly in terms of materials. And now we've had the perspective of scaling production equipment, gigawatt scale platforms, and how that can deliver on sustainability outcomes. Marion, thanks for joining. We've got more questions coming in, which I'm very pleased to see. And I really want to encourage you to continue to take part in the discussion as we welcome our first guests, our guests for our first panel on this Sustainability Roundtable. So it gives me great pleasure to welcome Michele Vanini from Coveme, Bertrand Lemkowitz from PV Cycle, Tom Romans from Vito, and Esther Foroshatzi from IMEC to our first panel to discuss some of these issues that were raised this morning. Thank you very much, all of you, for joining us.
Thank you.
Well,
Thank you.
Michele, I'll start with you first. Coveme is in the business of supplying materials for PV module production. We heard from Pierre Verlinden some of the challenges at this very huge scale to which, towards which we're heading. Some of the silver consumption is really remarkable when we're heading to such huge volumes. How do you think the PV industry should be preparing itself for these challenges as we head towards terawatt scale on a materials basis?
Thanks, Jonathan. Yeah, this is I really enjoyed the presentation from Pierre, and it really touched on the points that we are very passionate about. So at the end of the day, we need to keep in mind that we need to recycle the panels, those panels, and what we need to do is to avoid landfill. Basically, today there is a minimum recycling, and most of what we do goes into landfill. And so we need to go to a second step, a phase 2, which is pretty common nowadays, with a higher value recycling. and even going to a phase 3, which basically goes 100% recycling and no landfill. So that's the dream. That's what we need to do. So we need to focus on technology. What today we do is a mechanical crushing and some of the thermal processes. We heard from Pierre there are some chemical processes that we could implement, but are not very effective still today. We think we need to design product with the end of life in mind, and the products that are easy to recycle at lower cost. I want to throw in something you and I already discussed in the past. We want to help the industry to have what we call a labeling system, where we can probably red label models that are more environmental, with a more environmental impact, and a green label maybe with modules, and in our case with backsheet that are more virtuous. So maybe the red label will incur a higher cost to take back and dispose. So that is the frame we see in the industry. And I would like to ask to my colleagues the way they see it.
Okay, well, design for recyclability. I think that's an interesting point. And we do have on the panel Bertrand Lemkowitz from PV Cycle. PV Cycle really is the premier or the leading body in terms of the recycling of PV modules at end of life, particularly in Europe. Bertrand, what do you see about recycling, and particularly in the framework of terawatt scale? How much do we have to ramp this up?
So basically, recycling is not a big issue. Today, we are able to recycle technically up to 95%, 96%. So I mean technically, because all recycling plants are not able to do it. So it's an average of 80, 85% today at the global scale. What's missing, actually, it's legislation. We need legislation to oblige people to recycle, because even if there is more than a lot of people who are thinking about sustainability, especially producers, there's always a part of them where the benefit comes first. And so those ones are going to landfill because it's cheaper, of course, to recycle. Even if we can recover a lot of material, recycling is still expensive because the process is expensive.
Indeed. So the recycling processes themselves, where are we at with these recycling processes? Can you bring us up to date in terms of the sophistication of what we've got today?
So the last technology, basically, it's quite simple. It's, as I said before, as Michele and Pierre said, basically we shred the panel. And then it's sorted by different technology, optical sorting, vibration for the density, magnet, Foucault stream, and all those kind of process to extract those fractions. Then we can recover, put those fractions into new industry.
Okay, well, that's a bit of a technical insight, and thank you for that, Bertrand. You did make the case that legislation or regulations are required. I imagine also on the business side, business models as well, we need to have a financially sustainable recycling sector. Tom Rommans from Vito, you're the coordinator of the Circusol initiative, which is an EU-funded project looking at not only recycling and end of life, but also reuse and some of these other applications for PV modules once they are nearing their end of life. Tom, how well is the industry set up on the business side, on the logistics side, for a recycling of modules?
Yes, thank you for having me. Well, we've heard about technology in the first place, recycling technology. We've heard someone asking for legislation. We think there's indeed also an important factor, and it is the business model as such. And we're looking into new ways of organizing this business in order to make sure that materials are getting back to the right party within this supply chain, to make sure that it is, for example, reused or refurbished, instead of being recycled or, well, in the worst case, landfilled. What we think is that we need to shift to a model where we try to sell services instead of products. What we see today is that there is a linear supply chain. PV panels are sold to the end user. And then in the end, it's just up to the end user to decide when the panel is nearly end of life to send it back to recycling in the best case, or to landfilling in the worst case. And we think there are other options. If you think of selling services instead of products, you would have a system where you sell performance to the end user, and the end user just pays for the performance of the panel, and the actual ownership would stay in the hands of the dealer, for example, or the manufacturer. And it's getting more easy to organize reverse logistics and to also organize systems like remanufacturing or refurbishing.
Okay, Tom, I'll jump in here. So you're talking about solar as a service, which is kind of solar leasing or third-party ownership, which we actually see more of in the US, in the United States, than we do in Europe. But you are also touching on refurbishment and some of these things. I want to bring Esther Foroshatzi from IMEC into the conversation at this stage. Esther, IMEC is one of the partners in the Circusol initiative. Can you we hear these terms, the reuse or refurbishment. What technically does that mean? What can we actually do to get a longer life or a second life out of PV modules?
Indeed. Thank you, Jonathan, for bringing this reuse point. I think it's very important to add in a truly circular PV system. As Tom says, we would need to go away from this linear way, and in the circular, especially for very robust PV modules. Pierre already gave us the example, PV modules can last 30 years. So when they end their first life on a PV system, we could really think of reusing, giving them a second life. And we started to look into this sector, and what we've understood, and I will join the others, I will call for more technology and also legislation. In terms of reuse, we clearly see some operators already very well operating in the reuse sector, taking back sorting modules, labeling them, and then reselling them. But this is a very small majority, and nothing obliges actually to handle this way reuse modules. So I would really see reuse modules have a large potential if we would have a minimum technical sorting requirement set up. A very, very light standard, I would say. Something like the IC 215 that became the basis for module quality. Well, a very light version for sorting PV modules on site would be very useful for the reuse sector. This way, we could really create a trust in second-hand modules. And if we would have this trust, quality insurance for second-hand modules, I think there is a potential there to really make PV modules sustainable, run until their end of life. And obviously, think about recycling and not the landfill, as many other panelists already advocated for this.
And what do we mean by kind of revamping or extending the life of modules?
So there, I would really also see that if you look into research, you see that some of the module failures we observe on the field can be really repaired. So this is where we could talk about revamping. If you look at the external shell of the module, something like the ER coating or the backsheet of the modules, they could be repaired. Technology exists to repair them. So this is one of the routes. If there would be legislation and an environmental push to make this happen, technologies are there. Next to this, also bypass diodes, all the electrical components attached to the module, we could also repair them very easily. But one would really need to think about this in the module design phase, that modules become not just designed for recycling, but designed for repair. These two should go hand in hand. This way, we could really use modules up to their 30 years of life, which is one of the bases, as Pierre already mentioned, of sustainability, to have modules last long.
So durability and extending this life
durability,
is also...
Exactly, durability and high performance. So really let the modules revamped, repaired to function at a high performance ratio.
Okay, Esther, thank you for that. Marianne, I want to bring in our audience questions at this stage. We are getting quite a lot of them in, even at this early stage. Marianne,
absolutely.
what would you like to add?
Well, yeah, absolutely. Our community has been very active in posting their questions. And I will send the first one maybe in Tom Roman's direction. So the people are asking whether the recycled modules can actually be used in the PV industry again, and ask about any risk of downcycling, so that the recycled material in the end isn't as good performing and not up to the standard. And I might extend on that question a little bit and ask whether the materials that we can retrieve from modules that are 25 years old are still needed by the PV industry in today's module manufacturing.
That's a good question. There's two ways of looking into this. One is, just from the performance perspective. We all know that the panels are getting more performant every day. So, of course, these old panels aren't as efficient as the new ones. But what you see is that from the environmental perspective, there's always a benefit of using panels for a longer time. So you will never offset the additional environmental burden that you introduce into the system by installing new panels. You will not offset this by the fact that these new panels are more efficient. So there's always an environmental benefit of using installations longer, even though they are less efficient than the new ones. That's for sure.
Okay, and Marianne, I might just follow on from that. So durability is really a key metric, whether that is revamping or just making modules for a long life. Michele, of course, from Coveme, durability is informed by backsheets. Backsheet is a key component for durability. Is there a tension there between the use of fluoropolymer materials, which can extend the life of a backsheet or have been proven to be very robust, and then other materials which are much more easier to recycle?
Well, I think the most important thing to me would be to have the proper frame to allow good material to go through. So we need to keep developing new and more performing material with better end of life. So we need to be very smart in doing this. So we don't have to leave out good materials. And having said that, there are materials that are easier to recycle compared to others. Obviously, if you go through a thermal recycling process, you don't want to have HF in the air. So that will set the tone. If you have material with fluoro, that will cost more to be recycled. That goes without saying. So we need to be very upfront with that. So there are choices that are easier to recycle and to avoid landfill. I think that's the cost. If we have that in mind, we can design better material. And yes, to answer to your question, there are materials with fluoro that are more difficult to recycle and to avoid landfill. Yes, it's true.
And so you mentioned earlier this kind of your idea to have some kind of labeling or certification process whereby modules that do have materials that are more difficult to recycle could be labeled as such. That's a solution that you potentially could see.
Yes, and I agree. I go back to what the panelists said. Legislation is key. So we need to have legislation to back it up. And labeling is an idea. We could have a red label or green label or white label, depending on how difficult is the material to recycle and how much you can recycle out of that panel. I think that's an idea. That's already been done in some part of the industries. There is a technical literature about that. So I think we could easily implement that. Obviously, it's a trade-off between the cost, your overall cost, and the development cost. But I think we have the technology to do it and to do it in a safe and sound way.
Okay. Marianne, would you like another question from our attendees?
Absolutely, absolutely. And so we do get questions about mineral supply, and people are specifically asking about indium, and informed by Pierre van Linden's presentation earlier. about silver, but I will open that question to more minerals that can become short in supply as we're moving along with expanding the PV industry. And I think Esther will be in a good position to answer this question at this stage.
Yes, definitely. I can comment. I've seen the questions that are coming up on silvers, indium, bismuth also. So in all cases, for the moment, in the design, certification, looking for new materials, the sustainability hasn't yet entered the stage. What has been the driving factor? So in this sense, technologies or materials do exist, but they didn't yet get enough R&D focus from academia and the industry to really qualify them and develop them for PV, massive PV use, but there are solutions. So what I would recommend that it really needs to get our attention with this new sustainability-minded eco-design of PV modules.
And in particular, silver, one of the most popular questions we've had exactly. Is, what are the alternatives?
I've really seen, so has been, in technology-wise, copper plating has been proven to be scalable, industry relevant, but hasn't taken up. So this is one of the very well-proven alternatives to silver, where minimal silver usage would be required if one uses copper as main conductor in solar cells.
Well, Bertrand, from a recycling perspective, come on, silver, some of these rare earth minerals, indium, this is valuable stuff. Surely there's a business case then for recycling these materials from PV modules.
Actually, not really. In terms of recycling, the main component for us is the copper cable and the aluminum frame. For all the rest, it's really low valuable material in terms of recycling. So there's a lot of glass, but low value. Okay.
Well, sticking on recycling then, we have questions about, like, how should we make module manufacturers responsible for the end of life? Is there a way we can implement that?
So actually, it's the fact in Europe, they are responsible for the end of life in Europe thanks to the WEEE legislation. The problem is outside Europe for the moment.
But does that even extend to the materials? As Michele set out, some materials are easier to recycle than others.
Yes, actually, so it's in terms of designing the product to be able to be or refurbished or recycled or repaired, the 3R should be really fine and should be obliged by legislation also to design the product based on the end of life or the future life of the product.
Okay.
So we need a legal frame for this.
And so it's pretty much unanimous. We need a legal framework, and we are going to be speaking in our next panel discussion about some of the efforts in the EU underway today. But why aren't we seeing enough movement there? Or are we seeing things heading in the right direction? I'll stick with you, Bertrand, on this one from PV Cycle's point of view.
So can you say it again? Sorry.
So why, if it's so urgent, if we all agree that we need regulation and sophisticated regulation, what progress is being made?
So actually, it's a quite new product. When you think about it, we are using PV since the 90s in quantity. So having a legislation with a product who's now 30 years old, with a life shelf of 32 years old approximately, as you said before. It's normal. Today, the quantity of panel to recycle are not so huge, so there's no huge emergency, so they need to think about it now for the future, because the panel we're gonna build now gonna be recycled in 30 years only. So, but yes, it starts to be really an emergency to think about the process, the legislation, implement things in Europe and other parts of the world also for this. So,
sure.
Building legislation to avoid those kind of problems in the future.
Okay, thank you, Bertrand. Marion?
I have one last suggestion, or another suggestion from the audience here. People ask, we have talked about PV as a lease model, PV as a service, and people are suggesting why not have raw materials as a service, a lease model for raw materials that would incentivize to retrieve them.
Maybe
the
Tom,
PV
you're in a
industry.
position to answer that.
I think that's that's an interesting suggestion, and thinking about legislation as well. We should be careful in the way we put these new responsibilities for manufacturers, for example, in the law, because we have to avoid that we focus, for example, too much on collection. If you just focus on collection, you don't care about what happens after collection, and that's what we see right now. I think you collect, and there's a high rate of collection, but in the end, what happens effectively in the recycling part, and how much of the materials are reused effectively, and how much of the silver, for example, which is difficult to recover nowadays, how much is still lost, that those are things we aren't really monitoring on in this stage. So that's a very important thing to take to keep in mind for the future. If we go to new responsibilities for the manufacturers, should we make them responsible for collecting the waste in the end? Should we make sure that they recycle? Should we make sure that they also leave a possibility for refurbishment or reuse? Should they be responsible to produce their products in another way and to design them in a more sustainable way? Should they be responsible in the end for the material use and the material recovery? That's going very far, but it's an interesting thought, I think, and those are things we should keep in mind when asking also for new legislation, because if we don't create these new frameworks in the right way, we could end up with some results that we don't want, in fact, and there could be some lock-in effects, and we will maybe run into trouble.
Okay, so
those are interesting things to think about.
Yeah, so there are risks and some along with the opportunities. I can imagine one of the risks is cost, right? Like PV has become incredibly cheap, which is a wonderful thing for climate change. It's a great thing for the world. Esther, I see you nodding here. Does some of these initiatives, some of these programs incentivizing sustainability, recycling, will it add prohibitive cost to PV?
Michael, I don't think prohibitive cost, but we might need to put other metrics than cost only to PV modules. So it could be that if there is an ecolabel that and the labeling of sustainability, that it will be a parallel metric. So yes, in some cases it might be a bit more expensive, but on long term it will be more sustainable. And I've also seen, and I also like to add to it, that in sustainability, that we talked about different business models, I really see the local element coming up. So yes, sometimes maybe more expensive to repair locally instead of shipping around globally, but it will be more sustainable, create local jobs. So I think it would worth it.
Okay, Michele, I saw you nodding also. How do you see, as a material supplier, the balance between sustainable materials and cost?
I mean, it goes back to what we said before. Legislation is key. Labeling is a good way to do it. Some of the committees of the European Union are already investigating. I think there is obviously anything about the EU it takes a long time to have 27 countries agreeing on something. But I think we are in the right direction. I think we need to be very smart and develop product with the right materials. So we don't have to be. It's not rocket scientist anymore. We just need to be very, very wise and go with the proper development. So labeling is the way we feel passionate about it. We need to have a label that says this material is less environment, or it's better from an environmental point of view, from a recycling point of view, from a disposable point of view. I think that's the way we have to go.
Okay, and so we shouldn't look at restrictions. One of the questions is fluoropolymers. Because they cannot be recycled, should their use be restricted? Michele, you're in the backsheet business.
I think we need to be, as I said before, we need to look to materials that, and we need to be open. Do not be, we don't want to leave out good materials. At the same time, we don't need to keep using the same old material if we have a better material to use it. So we need to be very open. So, and I don't want to use landfills. So we need to find a way to avoid landfill. So the two things combined together will set up, somebody else will decide what are the best material to do it. From my perspective, I don't see we need to go to landfill. I think that's stupid, and we need to do everything to avoid it. And if using fluor is bad, so let's don't use it. So that's basic. But we have 1,000 of different examples in the industry. Cadmio is one of the samples already. People already discussed. So there are a number of things, and so you can probably, you're better off to find out how many material we could replace or we use differently, I think.
Okay, thank you, Michele. So it's a balance between we don't want to cut off our nose to spite our face, is the saying. But we have questions about other kind of potentially toxic materials. I suppose they're kind of the villains in terms of sustainability within solar. Marion, would you like to go through some of those?
So people are talking about that the PV cycle and circular solar are, of course, always centered in Europe or North America. But what about all the other regions in the world which are now really catching on to the solar industry? What can be done to bring them to consider recycling at a greater scale and to integrate that? And maybe Michele can answer that.
I think Bertrand, maybe from PV cycle. So the regions in particular, things like MENA, which includes Africa, South America. What's being done there?
So actually, there's no local incentive. I heard about some legislation in Colombia. I know we have a lot of requests, South America, Africa mainly today, with some requests, Colombia, Argentina. There's Mexico, it's mostly a communication issue because they have some question, okay, what are you going to do with the waste later? And they don't know what to answer, and they kill their own business by don't give any answer. So they start to think about it also because of the public opinion.
Okay.
But yeah, things are going on. It start to move also in those kind of region. We already collect in Panama and Senegal last year.
Okay, so PV cycle is definitely leading outside of Europe also.
Yes.
Yeah, excellent.
Definitely. The only issue, there's actually no recycling plants over there able to recycle it. We are investigating some solution, local solution to avoid to ship the waste to Europe. Mm-hmm. And avoid CO footprint on the logistic part.
Yeah. Okay. So you mentioned logistics. We also have a question about logistics. In terms of recycling, how big is the logistical challenge? Tom, I know that Circusol is looking at that because the technology is only part of the equation.
I think. PV Cycle is also one of the partners in our project, and they know how difficult it is. And as Bertrand already said, I think the problem today is that there is still only a limited volume of waste collected, just because most of the panels that we have installed are not really end of technical life yet, and it's a problem for the future, I guess, and once volumes are going to get bigger, costs will go down probably, and it will be more achievable to collect the panels and to give them a good second life or recycle them in a sustainable way. It's always a matter of cost, of course, and in the waste business in general, the flows are just going into the direction where the costs are lowest. Just to come back to the previous question, what we also see is that talking about Second Life, you see that there is a market for Second Life panels, for example, outside of Europe. And one of the problems you have is that if you try to organize a Second Life market inside of Europe, you have competition with these flows that are leaving Europe. So trying to get the model rights in Europe is maybe also going to create some room in the other countries to do other things with their waste there. I mean, we have to try to think forward and to give the right example in Europe, and maybe we will get some followers in the end outside of Europe. That's what we hope.
Okay, Tom Robbins, thank you very much. I think that's a good place to leave our discussion. Thank you very much. Of course, read PV Magazine Global. We have some interviews with some of our panelists in the June edition and in following editions. Michele Vanini from Coveme, Bertrand Lemkowitz from PV Cycle, Tom Robbins from Vito, and Esther Ferroshatzi from IMEC. Thank you very much for your time, and thank you, Marian.
Okay. Thank you.
Well, I mentioned earlier that this Sustainability Roundtable is a part of PV Magazine's UP initiative. Now, the UP initiative was kicked off last year, really trying to foster a discussion of sustainability within the solar sector. It was initiated by PV Magazine's head of content, Becky Beets. She's the woman behind this discussion today. But what's behind the UP initiative and how can you get involved? Becky's prepared this short presentation to set out the details for you.
Hi, I'm Becky Beets, Head of Content at PV Magazine, an instigator of the UP Sustainability Initiative. We launched the UP Initiative at last year's Intersolar Europe with the aim of diving deep into what it means to be truly sustainable in the solar PV and energy storage industries, examining what has already been done and discussing what still needs to be addressed. A part of this has been the launch in Q4 2019 of our quarterly themes, which shine a spotlight on key issues. The first looked at the use of lead in crystalline silicon solar modules. This is an interesting discussion because it's possible to manufacture PV panels without lead, as companies like SunPower have demonstrated, yet it's not common practice. We looked at why so many choose a lead-lined pathway and investigated sustainable alternatives that could be a viable option. The first quarter of 2020 honed in on raw material sourcing in batteries, which is becoming an increasingly crucial issue. Key topics we addressed here included fair lithium from Chile, ethical strategies for cobalt mining, and zero-waste batteries. The current quarterly theme is looking at green finance, particularly in the context of the climate law proposed by the European Commission in a post-COVID-19 world, which could reap many sustainable benefits if policymakers are bold enough to take the opportunity. In the third quarter, we're going to shift our attention to circular manufacturing, which was the focus of the first roundtable session on sustainability. We've also introduced a sustainable category to our annual award program. This recognizes those companies demonstrating successfully integrated sustainability business strategies at a company level, or which have concrete intentions to improve current operations. Last year's winners were First Solar and SunPower for their pioneering work in the field of solar sustainability. So why focus on these issues now? 2015 was an historical year for the climate, with the unveiling of the 17 Sustainable Development Goals as part of the 2030 Agenda for Sustainable Development, and the Paris Agreement, which saw 193 countries committing to undertaking ambitious efforts to tackle climate change, chiefly by focusing on achieving zero emissions. These plans identified the risks and opportunities climate change are bringing, and laid the framework for how we need to address them. They also provided a glimpse into the types of policies, regulations, and legislations required and will most likely be adopted in the coming years. It further highlighted where investment, public and private, will begin to flow. Since 2018, the public's calls for change have also intensified, bringing with it a new climate movement. Solar PV and energy storage sit at the heart of the required energy transition. Their goal is twofold: to deploy as much capacity as possible, as quickly as possible, and to pioneer a new way of doing business that sees a just transition to clean manufacturing and sustainable business strategies. There is already a huge amount of work being done. As we've just heard in the previous session, Circusol, a Horizon 2020 programme of the European Commission, is seeking to not only unearth new business opportunities, like solar as a service, but to also look at the redesign and recyclability of solar products, among other issues. The Green Manufacturing Consortium, run by the Fraunhofer ISA, comprises 20 industrial partners, 4 institutes and 2 industry associations. Their objective is to develop an economic ecological evaluation methodology for a sustainable future factory for the production of innovative PV modules. And then there's the creation of the first specific sustainability standard for modules and inverters. This is set to establish product sustainability performance criteria and corporate performance metrics that exemplify sustainability leadership in the market. And this is something that the upcoming session will focus on. No one government, business, or person, however powerful, can handle the issue of climate change alone. Likewise, there's no room for complacency on the individual level. Everyone will be affected at some point along their value chains, the solar and energy storage industries included. Thus, systemic thinking, strong partnerships, and multilateral cooperation across governments, industries, business, and borders are essential. We want to use our global platforms and integrated networks to connect, collaborate, and cooperate with the solar and storage industries on exciting and innovative projects like the ones I mentioned, and to support other future efforts. So step up, join up, and become part of the uprising today. Email up@pv-magazine.com for more information. And enjoy the rest of the sustainability sessions today.
Okay, thank you very much, Becky Beats. And I do encourage you to get in touch if you would like to be a part of the UP Sustainability Initiative. Really some good work going in, and it's an important discussion, as we've heard in our first panel. We also heard about the importance of regulation in terms of enabling PV recycling, enabling more sustainable practices, and also the role that things like green labels or eco labels can and do play in fostering sustainable practices within the PV sector. We've got a great panel right now to address some of these issues. We have panelists joining us from all over the world, and in particular from California, and we're having a few technical issues. It's the middle of the night or the wee hours of the morning in California, so some of our panelists might be a little bit delayed in joining us. I know that we've got 3 on the line now, and everything is working fine. Nancy Gillis is from the Green Electronics Council, and she joins us. Andreas Wader from First Solar and PV Thin, and Jürgen Reinhardt, who is the CEO of SMA. I'd like to welcome our first lot of panelists, and hopefully as we wake someone up or get the audio working for everyone else, we can have the full set of panelists. But for the 3 of you for now, thank you very much for joining us.
Thank you very much.
Hello.
Great. Well, Nancy, I'll start with you. You've really put in the big effort to be here, and it shows just how seriously and important you believe sustainability in solar is. So can you set out from the start, why do you think it's so important that the solar industry is not just good enough in producing clean energy, but actually adopting sustainability as one of its core values?
Right. Thank you very much for that question.
So the Green Electronics Council, we are a mission-driven nonprofit wanting to see a world of only sustainable electronic products and services. And simplistically, it's because we understand that there's tremendous benefit to the world based on these electronic products, but that there's also a cost. And so we're selfish. We want to have all of the good while still mitigating the bad. And so we think for the solar industry, there's been a tremendous amount of conversation, of course, about the benefits of solar as part of the renewable energy solution to climate change. But we don't think that it's acceptable to have that solution based on non-sustainable hardware. And that's why we've been very active, as we'll talk about in today's session, in actually partnering with an organization to create one of the first standards on what it means to be a credible, sustainable PV module, and to then actually apply that to an ecolabel that is able to be used by institutional purchasers, so governments and large-scale purchasers across the world. Because we really, again, think that it's now the time to have PV modules as the renewable energy solution to climate change be on a very sustainable base.
Okay, well, bring us up to speed then. Of course, we've known about certain initiatives that have come out of your part of the world informing sustainability in solar, starting with the Silicon Valley Toxics Coalition and their solar scorecard. Can you talk us through the genesis of some of the standards and the labels that you're speaking about? I'll keep the conversation with you at this stage, Nancy.
Absolutely. So as you mentioned, the Silicon Valley Toxics Coalition, they actually created a scorecard, and that was that first set of criteria that you started seeing, and that was at least several years ago. Then our organization, the Green Electronics Council, actually took the beginnings of that scorecard, and we developed a process, a voluntary consensus process, that brought together the voices of purchasers, of policymakers, of manufacturers to develop a second set of criteria. And this is now the standard that was put out by NSF. It was actually facilitated and actually financially supported by my organization, the Green Electronics Council. And then the Green Electronics Council has now taken that standard, and we've taken those voluntarily created criteria, which is very important because criteria really need to not only reflect what policymakers and the nonprofits and the advocacy, environmental and social organizations think is necessary for photovoltaic modules to actually be credibly sustainable, it also needs to have the voice of industry, those who actually then are required to meet those. So that voluntary process put together those criteria. And those criteria are also ones that are life cycle. So as I think was mentioned in the last panel conversation, you need to be able to look at not only the aspects of extraction and mitigating the environmental impacts there, but the manufacture and assembly process, and also the end of life. And so you've got this process that started with the Silicon Valley Toxics Coalition scorecard. You brought it through a voluntary consensus process. You've got now brand new criteria, and what's that last step that we're at right now is you have an ecolabel. And that's the ecolabel that my organization manages and has managed across a number of different electronic category products for the last decade. And that ecolabel is an important next step for the standard because, as we know, we currently find ourselves in an interesting time where there's a lot of national focus and not necessarily as much global focus. Well, in the world of standards, there are several countries who only want to use their own standard and not necessarily standards that are created elsewhere. That, though, doesn't apply to ecolabels. So the ecolabel my organization runs, EPEAT, is a global ecolabel. So now you have the opportunity for these criteria that were voluntarily created to be applied and then to be used across the world, creating a harmonized baseline of performance that actually leads to credible sustainability for PV modules. So we're super excited about that. And that's kind of the progression that we've seen. And we're now at the point to where our ecolabel EPEAT will be launching the category. So products will be available for purchasers no later than September of this year. So we're very excited about that.
Okay, well, and let's dig into how the EPEAT eco-label is going to drive demand a little later on. Jürgen Reinert, I'd like to bring you into the conversation. You are the CEO of SMA. We do talk a lot about modules when we talk about sustainability and these discussions. What do you see the role then for power electronics and inverters?
Yeah, I mean, I think it's likewise important, just as important. If I start with the big picture, of course, we all know how cheap solar energy has become, or cost-effective, rather, I would like to say. And we are on the way to a terawatt scale within the next decades and the next years, actually. And of course, we have come into the observation of the old industry, of nuclear, coal industry, etc. And I've been myself within meetings where there has been a lot of fear, uncertainty, and doubt placed by the older industry onto our customers on cybersecurity, but definitely also quality, lifetime, uptime possibilities, etc. So I think there's no doubt in my mind that the sustainability issue is one of the really decisive factors for our industry as a whole, independent of if it's module manufacturers, battery manufacturers, or inverter manufacturers. It needs to be sustainable. We need to make sure that we do not open up the possibilities for arguments from people who are against renewable energies to actually have a course of saying of why this technology is not performing as it should be. And therefore, I think it's extremely important that we have a label in the end that has very high hurdles, that does not lead to a greenwashing of the entire industry, because there will always be companies that focus more on sustainability, on quality, durability, lifetime, circular usage of resources. And there will be others who are only having the shareholder value in mind and actually not very interested in sustainability, even if they might say they of course are. And therefore, it's extremely important that we have a label that is worth the name, that has high hurdles, and that is being audited by external companies without any notification prior, in order to really be able to have that label. And I mean, in the end, it goes back to our customers. Our customers should be having the possibility to look at it very easily, transparent, need to understand how it is being tested, and it needs to be comparable. And therefore, it needs to be a global standard that is applicable. And most of our customers are international, and they need to be able to compare that in the different countries and differently need to be able to rely on that.
Okay, thank you very much for that, Jürgen. Interesting about the setting of the hurdle, how it should be set and how it should be enforced. I'm very pleased to be able to welcome Sheila Davis to the discussion from the Silicon Valley Toxics Coalition. Sheila, thank you so much for being with us at this horrible hour of the morning in California. It's really wonderful that you are able to join us. We were talking a little bit earlier about the scorecard, the solar scorecard that the Silicon Valley Toxics Coalition produced, and its role in informing the voluntary standard, the ANSI standard. Can you tell me more about the evolution of this scorecard? So tell us about where it started, and in terms of some of the settings that it did establish, and then where are you moving to? Because we don't want the standard purely as a baseline or as an absolute minimum requirement, as SMA's Jürgen Reinert was setting out.
Silicon Valley Toxics Coalition has worked on technology issues for many years, many decades actually, and we started off working on the computer industry, and we've developed scorecards over the years, primarily for the computer industry, and then of course we transitioned into the solar industry. But the computer industry and the scorecards, everything from toxics to comparing companies, we've used a scorecard basically for our advocacy tool for campaigning, whether it was with shareholder meetings or whether it's trying to get companies to adopt certain practices. We've used it as a tool to differentiate companies so that we can demonstrate who are the leaders and who are the laggards. And of course, most importantly, scorecards have been used to fill a void in terms of the laws, where there are no environmental laws and where there's really no shared understanding of what it means to be green. So scorecards have really played an important role for Silicon Valley Toxics Coalition over the years. And of course, the computer scorecard, when we were producing it, we have always had, we're a coalition because we have always had partners nationally and internationally, and we actually parlayed the computer scorecard into an EPEAT development standard. So we were among the first groups to actually develop EPEAT, and we kind of go way back with that organization. And we transitioned all the information from the computer scorecard to EPEAT and also the green procurement guidelines we had. And we also helped develop the EPEAT standard for computers that exists now, the early version of it. So when we started working on solar, I felt it was a natural progression to start off by developing a scorecard to do all the things that I mentioned earlier. Actually investors were the socially responsible investors were the first to approach us and ask us to develop a scorecard. And we worked with them very closely to do that. And we have basically, over the first 5 years, we basically kind of vetted some of our questions and the categories. And then after a while, we turned it over to EPEAT and the Green Electronics Council to develop a former international standard. So it's kind of a natural progression that we've been involved in. And now basically we're ready to kind of take it to the next level. We know that the industry constantly changes in terms of its technology. The environmental thinking constantly changes in terms of philosophy around environmentalism. And of course, there's changes in an understanding of environmental science in terms of the earth and ecology. And so for those reasons, we need to kind of keep pushing the envelope and develop new standards. So now we're working on the next generation of the solar scorecard.
Okay, Sheila, thank you very much for that. Well, we've already touched on the importance of setting the bar sufficiently high. There's also compliance. Andreas Varde, you've been involved in sustainability and solar modules for a very long period. What do you see the role of compliance with things like these standards and also with things like an eco-label? How important is it and how should it function?
Yeah, sure. Thanks, Jonathan, for the introduction. And I would agree that the moment we are at the moment in the industry, having a first international sustainability leadership standard, not only for modules but also for inverters. I mean that's certainly a big achievement here. Is a pivotal moment where we can really step up to the next level, because we will have a common reference to use on all the aspects which also have been discussed in the previous panel, right? Be it recycled content, be it design for recycling, be it life cycle assessment, use of hazardous materials. All these aspects are actually covered in this standard, and actually with the adoption in the EPEAT registry, we will have an independent verification mechanism in place where indeed manufacturers could comply with, right? So I think that point of compliance is indeed an important point, and I think that was also one of the reasons why we were always a strong proponent of taking the voluntary approach established by the SVTC scorecard into an international standard and then implementing a verification mechanism around that. Because as Jörg mentioned, it's not, it's certainly nice to have voluntary statements from manufacturers out there on, how they're addressing certain sustainability aspects. But if that is not verified according to a common standard, and consumers, as well as public purchasers, as well as institutional purchasers, have no possibility to verify that, it is simply not driving a sustainable change, right? So that, I think, is an important part here, which I believe will really be a step change, because having that baseline standard, having independent verification bodies, verifying the statements from the manufacturers, verifying the data, going into detail on the verification to ensure compliance is a major achievement. And then last but not least, and I think that's another point, touching on your previous question, I mean, the tiered approach of the EPEAT registry, having a bronze entry level and then a silver and a gold level, and ensuring that the standard which is used to assess the performance of manufacturers is continuously also evolving to step up with the progress which is being made in manufacturing, will ensure that the eco-label itself will always have kind of a leadership role, and then obviously, can ensure that, products which are, for example, gold certified are really in the top-notch, let's say 5% of the global market when it comes to the availability of the product, right? So there is a very strong incentive, obviously, for manufacturers to comply with the requirements there. And then maybe to just close the loop on also a previous discussion at the previous panel, I don't think that necessarily regulation is the most effective way to drive this change in the industry. Now that we have an eco-label, now that we have the standard which is being used to certify the performance of modules and inverters, I think the much more direct way to enable an adoption and enable a change in the industry would be to simply make it part of purchasing requirements, right? I mean, this is the biggest lever we can use, right? If in the tender schemes we see in Europe or in the RFQs we see around the world, the purchasers will simply spec in, hey, we will only purchase modules which at least fulfill bronze level or silver level of the EPEAT, then we will see a tremendous, momentum in the industry to, start adopting the requirements in there. And with these requirements, as I mentioned, go requirements on recycled content, on recyclability, on marking modules for end-of-life treatment and reuse, so that recyclers and reusers can actually easily make that happen. It includes packaging. So all these criteria are in there. So I think, the combination of combining that with public procurement requirements is actually much stronger and will drive much more momentum on compliance than the rather lengthy processes we see in regulation. I mean, we in Europe, we're discussing about eco-design, but that will take another 4 years, right? Whereas the standard is available now. And I think this is really one thing which I wanted to emphasize here.
Okay, Andreas, thank you. And we'll return back to some of the EU regulatory programs shortly. Jürgen, I want to bring you back just in terms of compliance to the eco-label. Do you have any concerns about the cost of compliance for manufacturers? Or I can imagine that it could be costly or onerous or slow down innovation. Are there any concerns from SMA's side in terms of that?
No, actually not. I mean, if we look at inverters, of course, I will be speaking for inverters. We have in an inverter, of course, the housing, aluminium or steel. We have a lot of copper. We have 1 to 7 PC boards in one inverter. We have, of course, the semiconductors today mainly silicon-based, but also moving more to silicon carbide or gallium nitride, etc. So there's, of course, a lot of things we need to make sure, because they're coming from sub-suppliers, sub-suppliers, and we need to have that whole chain under control. Another part that is really also gaining costs or adding costs is really, of course, if we have a look at lifetime of inverters, all the components are subjected to exothermic processes. So if you have 10 degrees increase on temperature, you normally in the normal operation, you normally halve the lifetime of each component, and that is then needed for design reserves. You need to have a little bit more capacitance in your capacitor bank. You need to have a little bit bigger current capability in your IGBTs, so your semiconductors, etc. And that is things that, yes, they do cost money, but I would definitely think they will pay themselves back over the lifetime if we look at the entire life of the inverter, which shall be designed for 20 years and not for 5 years. So I do think that is the one part, adding costs, but it's definitely worth it, and that can be shown and also audited. And the other part is, of course, making sure which substances are used in your PC boards, in your manufacturers, sub-suppliers, etc. But I think, yes, it will, and it does go into the CapEx, that there is some extent of that always. But I'm very, very sure over the lifetime of a PV inverter in the field, meaning the ability to be able to replace it or make board swaps in order not to replace the entire inverter, it will definitely more than pay back, because it's much more sustainable to really make sure you have a design that covers these. And therefore, the eco design based on the NSF, where we've been so that with the NSF on the ANSI standard, where we've been involved also as only inverter manufacturers, then going into eco design and finally ecolabel, I think would be a perfect way to actually show this, prove this, and make this available for the customer, the distributor, especially the installer, and the end customer to understand in an easy and comprehensive way.
Okay, thank you, Jürgen, for that. We have a number of questions from our attendees about the NSF standard and also about the EPEAT eco label. But I do have great news. Joining us now, also at a terrible hour of the night, is Dustin Mulvaney from San Jose University. Dustin, thanks so much for joining us. Now, you literally wrote the book on solar sustainability. What we've been talking about at the moment is some of the evolution from the solar scorecard, in which you were involved, into standards, the NSF standard, ANSI, and now we're at the EPEAT stage. How encouraged are you by the development towards a more sustainable solar sector that we're seeing at the moment? Is it encouraging?
I think it's definitely been a major change since where we started. We started really, there were very few companies reporting any information about any manufacturing processes or about anything with their supply chain or what was in their actual products, any of it. Maybe 2 companies, 3 companies, and now we're seeing much more disclosure, a lot more information, a lot more people trained, understanding, thinking about sustainability coming into the industry. So I'm very encouraged. I think we have some spots that we don't have very good information about and stuff like that in certain areas, but by and large, I think if you look at where the electronics industry was at this point and such in its evolution, it's much more embracing of sustainability ideas, and I think that that's really important.
What were the areas that we don't have so much information on? I think your signal cut out for a second.
I would say labor standards in some developing countries that we don't have a good sense for, what's happening in communities that have different kinds of manufacturing activities.
Okay, interesting. So that's sustainability also from a human standpoint, not only environmental.
For sure, yes.
Okay, now, Marion, I want to bring you in. We do have these questions. I think they're probably best applied to our American guests on the NSF standard.
Exactly, yeah. The question are directly about the NF standards, and we have talked about a lot about standards today. And people, I think the most interesting question is, did this shift the choice of modules and materials? So really, are we reaping the fruits of these efforts at this early stage of this journey? And maybe, Nancy, you can comment on this. Are we seeing any improvements so far already?
Well, I think, we've been seeing improvements of that progression from having started with the scorecard and then already transitioning to the criteria that now are the basis for the ecolabel. But as was discussed, I think one of the benefits of having a global ecolabel is that you start seeing impact at scale. And as Andreas had mentioned, this is then moving the entire industry, be it for modules and inverters, because the ecolabel does address both. And it creates an opportunity for there to be a focus at a scale level to where you actually start seeing change. So I think right now, without something that actually coalesces the entire sector clearly, so without a set of transparent, publicly available global criteria that can be used, it's hard to say that you're actually going to start seeing change. I think that's where we've seen the role of ecolabels in other product categories as well, right? We've seen the incredible increase in efficiencies environmentally in the computer, laptop, and tablet categories. You've seen it in mobile phones. You've seen it in television, in servers, which is driving the efficiencies environmentally, and also the social sensitivities in servers and cloud. So this idea of adopting an ecolabel that's applicable globally to bring a set of criteria that are then transparent and available so that the entire sector knows what to move towards, to then also see a change at scale, that's not new. And I think that's what we're going to start seeing now.
Thank you. And going forwards, you mentioned that a global standard is really necessary to address this issue. Well, staying at the domestic level or at the country level at this stage, Andreas Wade touched it earlier, but you can implement public procurement requirements on sustainability criteria. Should governments really pursue this and implement minimum baselines, or if you implement these standards, should they actually be really progressive and trailblazing rather than setting, the minimum bar? And maybe I open that question to Sheila at this stage.
Well, let me first, real quickly, make a mention of what was said about baseline versus non. So just that it's clear, this ecolabel and the standard criteria that support it, as was said, has a baseline of bronze. So that can start clearing out those things that aren't the modules or the inverters that aren't credibly sustainable. But then it does have a silver and a gold level. So this already thinking about innovation. So those companies who, as was mentioned, really are focused on sustainability and want to highlight that, are able to pick a different tier level. And purchasers have already, over the last decade, in use of this ecolabel, clarified what level they're interested in. And if they're truly committed and see the benefits of it, will either just say a bronze level, starter level, or will actually ask for a silver or gold level. But Sheila, I know you've been active in that space as well.
If the question is whether or not it's more effective to have some type of laws or to have an ecolabel that's widely adopted internationally, or if it's better to have countries to actually have the government develop procurement standards. If I'm understanding the question correctly, I would say that it's not necessarily effective to have governments develop laws around procurement standards, because especially in the US, they're frequently so different. They might be different at the local level or the state level, or they might not buy into it at all. We have seen a lot of impact when we've asked the federal government to adopt procurement standards. But of course, year by year, the politics around the federal government unfortunately change quite a bit, especially lately. So difficult to ask the federal government to do anything, but in the past they have been very effective in terms of moving the ball with green procurement. And some local governments, like for example, the state of California or the city of San Francisco or spotted cities throughout the country are very effective at pushing the envelope in terms of adopting procurement standards. But it's probably most effective to have an eco-label, again, that they can use and adopt are relatively easy. That most procurement managers or officers are at the state or local or even at the company levels. Anybody that's doing buying wants to make it really easy. So the label, of course, makes it very easy. And that's what we've worked on over the years. But I do want to say that it's also effective to make sure that you have some basic laws around sustainability that do push companies to move, as well as to push procurement officers to move on sustainability issues. So I think all of the above is really important to have the procurement managers to actually have a good eco-label and to push on green procurement, but also to have good laws and good advocacy around these issues for customers and for the general public.
Okay, Sheila, thank you very much for that. I just want to jump in and direct this to you, Dustin. You've been looking at sustainability in solar modules for a very long time with the scorecard from the Silicon Valley Toxics Coalition. One of the questions is about the majority of production in the PV sector, this is particularly modules, occurs in China. How much transparency is there, and is transparency an issue?
It is. It's in any industry has manufacturing where you don't see what's going on, has transparency issues, and particularly in a country like China where you don't have access really to move around as much as a place where Europe or somewhere else, you might see a bit of a difference. Even within China, we learned that there was a lot of variation in performance, and that often had to do with whether. I remember one manufacturer was near a lake that was important and sensitive, and that was regionally important. So the rules and regulations protected that lake, and therefore that region had stricter regulations. So to answer your question is about transparency and what we know, we only know as much as companies can report, and if they're audited and things like that. So I would say that we still have questions about all manufacturing, because it doesn't always capture certain things like accidents and stuff like that. It's usually trying to capture the regular performance of a factory. But geographically, we definitely have differences in transparency. I think that's pretty clear. But it's not unique to the solar industry. I think that's just unique to the countries usually. Okay, sure. Thank you very much for that, Dustin. And unfortunately, we have come to time here on our panel discussion. There's many more questions coming in, much more for us to discuss. We'll be passing on some of these questions, and I know some of you are taking part in our Meet the Speaker immediately after this event, and I encourage all attendees to please take part in that event if you have more questions or you would like some more information. But to our speakers, Dustin Mulvaney, Sheila Davis, Nancy Gillis, Andreas Wader, and Jürgen Reinert, thank you very much for your time and for taking part in our first Sustainability Roundtable. Thank you.
Thank you.
And thank you for your attention. Thank you for your questions. As always, there's too much for us to get to. We can't get to it all. But a lot of discussions, a lot of issues were raised. The role of materials, of certain materials in particular, durability versus toxicity, recycling, revamping and second life, standards, of course, and the very encouraging development of eco-labels and regulation. But we can clearly see that the necessity for sustainability with the solar sector is really emerging as, increasingly emerging as an issue of concern and something that we should be aware of and adopt to help facilitate our transition or our progress towards this terawatt industry that we're heading towards. In the next hour, I really encourage you to do take part in all the digital opportunities we have available, whether that be networking or continuing the conversation with some of the speakers and the panelists that took part today in this discussion. In terms of the Meet the Speaker Zoom rooms, you can actually meet Andreas Varda from First Solar right now. Sebastian Gutz from Fonedena will be there. Esther Forashatzi from IMEC. Nancy Gillis is sticking around from the Green Electronics Council. Tom Robbins, Jürgen Reinhardt from SMA, Michele Vanini from Caveme. So please do pass on your thoughts and communicate directly to our speakers. It is a great opportunity. You can also meet all of our Roundtables partners in their expo area on the app or via the chat. There's also a scavenger hunt, as Marion said early, if you want to have a bit of fun and take part of that. We'll also keep you updated as to all of the recordings of these Roundtables Europe's session in the coming days and let you know when they're available. And in fact, most of the presentations are already available via the app. Well, that's it for our first PV Magazine Sustainability Roundtable. Thank you very much for your attention. Thank you for your wonderful questions and participation. And thanks for your interest in what is a really important issue within the solar sector.